So we left off last time talking about postulates, which are facts that we know in geometry that don't need any sort of proof. And we talked about how when you have 2 points, there's only going to be one line going through those 2 points. Now, there are a couple more postulates that we're going to go over. So the first one we're going to go over is the ruler postulate. So when you're using a ruler to measure a distance, there's always a real number that corresponds to each point on the ruler. We call that number the coordinate of the point. So here's a ruler. If you were to use this ruler to measure, you're really always starting at 0, generally, and then you measure out to wherever the end point is of whatever you are measuring. And that point will correspond to another point on the ruler, and that tells you exactly what that distance is. So we call that number the coordinate of the point. So here, for example, is a line with points A and B, and if you were trying to measure the distance from A to B, you would need to know what the coordinates of those points are. That's really what you're doing. So you don't always have to start at 0 when you're using a ruler. You could start at 2 to be at A, and then just measure out to B. And then you would use the difference in the coordinates of those points to find the distance. Alright, so the points on a line can be put into a 1-to-1 correspondence with the real numbers, which is what you have on a ruler. And the distance between 2 points is the absolute value of the difference of the coordinates. Okay, so if you were to find x2 minus x1, and then take the absolute value, that would give you the distance. Now, the reason the absolute value is there is, well, really the coordinates could be, let's say instead of thinking about a ruler, think of a number line. And so if A and B fall on the negative side of the number line, but you're trying to find a distance, you're going to need to take the absolute value in order to determine what the distance is, because distance is never negative. Okay, so the distance between points A and B is also called the length of line segment AB. Let's do some practice problems. Alright, example 1, finding the length of a segment. So find each length. So first, find the length of DC. So we can see that D is at 4.5 and C is at 2. So to find the distance, or to find the length of DC, we would go ahead and take those corresponding coordinate points at D and at C, which are 4.5 and 2. We would subtract them, and then take the absolute value. So 4.5 minus 2 is 2.5, and the absolute value of 2.5 is 2.5. Alright, now let's look at the second one. We're trying to find the length of EF. So again, we're just going to use the coordinates that correspond to E and F, find the difference, and then take the absolute value. So we have -4 at E and -1 for F. So -4 minus -1, we take the difference, and then we take the absolute value. So you can see here how using the absolute value is necessary because we're trying to find a length. We're trying to find a distance, and that has to be either positive or 0. It can't ever be negative. So here we have -4 plus 1, which is equal to -3, and the absolute value of that is equal to 3. Now obviously with these cases, because these points are so close to each other on the number line, you could simply look at the distances, or the amount of, you could look at the spacing between those points to find the length. Alright, the next is, what about when you have multiple line segments and we want to talk about adding them? So when 3 points are collinear, so when 3 points are on the same line, you can say that one point is between the other 2. So for example, here we have point B, which is between points A and C. And over here, even though it kind of looks like it's in between, but because they're not actually on the same line, we would say that point E is not between points D and F. It has to be on the same line. They have to be collinear in order for you to say that a certain point is between two other points. Okay, so we next have what we call the segment addition postulate. So this says if B is between A and C, then AB plus BC is equal to AC. Same thing goes the other way. So if AB plus BC is equal to AC, then B is between A and C. So here's a visual for you to see what's actually going on. So if B is between A and C, that means they're all collinear, right? They're all on the same line. Then we can say that AB plus BC is equal to AC. So the length of AB plus the length of BC added together is equal to the length of AC. All right, take a look at example 2. The cities shown on the map lie approximately in a straight line. Use the given distances to find the distance from Lubbock, Texas to St. Louis, Missouri. Okay, so now we can see how Tulsa is between Lubbock and St. Louis. Now, because in the diagram, you know that from Lubbock to Tulsa is 380 miles, and from Tulsa to St. Louis is 360 miles. So, because they're all collinear, you can use the segment addition postulate to find the distance from Lubbock to St. Louis. So, the distance from Lubbock to St. Louis is equal to the distance from Lubbock to Tulsa plus the distance from Tulsa to St. Louis. So that would be 380 plus 360, which is equal to 740. So the distance from Lubbock to St. Louis is about 740 miles. Now you can see if Tulsa did not lie on the same line, if it were just a little bit further up or a little bit further down, then you can see how finding the distance from Lubbock to Tulsa and Tulsa to St. Louis won't give you the actual distance between Lubbock and St. Louis. So it is necessary that all three of the points that you're working with have to be collinear. All right, take a look at example 3. In the given diagram, xz is equal to 73. Use the segment addition postulate to write an equation, then solve the equation to find yz. Okay, so because we're told what xz is, and we're trying to solve for yz, we want to make sure to incorporate both of those in our equation. So we actually don't need to deal with this w here. So let's just focus on the line that has x, y, and z. So xz, the distance from x to z, has to equal x plus xy plus yz. Now we know xz is given to us as 73 and xy is given to us as 23. And then what we can do to solve for yz is simply solve this equation. And that gives us that yz is equal to 50. Okay, we have one more example. Use the diagram to find GH. Again, let's start off by writing an equation based on the segment addition postulate. And since we're trying to find the measure of GH and we have FG and we have FH, let's try to incorporate all of those into an equation. So FH is equal to FG plus GH by the segment addition postulate. And then we know FH is equal to 36 and FG is equal to 21. So we'll go ahead and substitute. And now we can solve by subtracting 21 from both sides, and that gives us GH is equal to 15. Now I know for some of you it might be pretty easy to just look at the diagram and say, well, it's just going to be 36 minus 21 and that gives me 15. But just as practice, we are going to write first that segment addition postulate, that information, and then from there substitute and then solve. It's generally good practice to be able to apply a postulate or maybe in the future a theorem first and then substitute for what you do know And that way you'll know that you're keeping track of what you already know and separating it from what you might think or what you might be assuming about a certain diagram, especially in geometry.